Hi there, Mr. Sutton here, bringing you the IM3 Honors Chapter 1, Quiz 3, Post-Practice Number 3 Solutions on Polynomial Terms and Definitions. This one's got a puzzle that goes with it. Let's check that out. So here's the puzzle for this one. They're asking, why does the U.S. Mint need a new building? And we have a whole bunch of kind of clues that we have to unscramble the word next to those clues and write it in the boxes over here. And once we've done this for all these questions, these numbers here, whatever letter falls in these numbers, we're going to put that letter above the number down in the box below. So for example, let's say that I do this number 1 here and unscramble this word, and whatever word I spell, let's say that, I don't know, we end up having like an E under this 15. That means down below in these boxes down here, I would put an E under spot 15. So we have to figure out all these words before we can fill in all these letters. So with that in mind, let's go and see if that actually is an E or something else. So let's go through each of these. I'll do 5 at a time here just so I don't have to do too much cutting and pasting. So our first question is a symbol used to represent a number. So let's see here. In general, if you're representing a number with a symbol like an A or an X or something, that is called a variable. So let's see if that fits in here. So if I do variable in here, we've got V-A-R-I, another A-B-L-E. Yep, that works. So that means that R goes in spot 15. Next up, a statement of equality. Well, there's a Q here, so that's kind of telling me we probably have equation is this word. Let's see if it fits. Yep, so we have E-Q-U-A-T-I-O-N, equation. So we have an E going in spot 9, and in 20 we have a T. There we go. Now this next one's a little tricky, a value that satisfies an open sentence. So by a sentence, they mean like an algebra kind of sentence, not like an English sentence. And if a value satisfies that, that means that it's the answer, it's the solution. Let's see if solution works. So we have S-O-L-U-T-I-O-N. Yep, that works. Solution. So 17 then is U. And now this one's a long one here. For all real numbers, a, b, and c, a times b plus c equals ab plus ac. So this is an illustration of the distributive property. So let me see if distributive fits here. It does. And we have D-I-S-T-R, another I, B-U, another T, I-V-E. Yep, distributive. So 8 then must be a D, and then 6 is going to be a V. So we're filling this in little by little. This last one now, an equation that expresses a relationship between measurements. Well, I already thought an equation did express a relationship, but they're saying between measurements. So we're being a little more specific now. We're not just talking about any equation, we're talking about an equation that has specific parameters like maybe height or mass or time. So that sounds more like a formula. And a formula is an equation, so let's see if formula works. It's a special kind of equation. So we have F-O-R-M-U, let's say U-L-A. Yep, formula. So that means O is 2. All right, we've got another 5 to work through here. So number 6, a number that is multiplied by a variable. A number multiplied by a variable is the coefficient. We're talking about that a lot, the coefficient of x or v or whatever. So let's see if that fits. Coefficient. Yep. So we've got C-O-E-F, another F, I, another C-E-E-N-T. Yep. So 21 then must be an E. All right, this next one's a little shorter. We have for a real number, for a real number a, the real number negative a. Well, a and negative a are opposites. Let's see if opposite works. So O-P-P-O-S-I-T-E. Yep, that works. And then for, that means 23 then is going to be an S, and then 12 gets a T. All right, next one. For a non-zero real number A, the real number 1 over A. So these are both kind of inverse sentences here, but this is a specific type of inverse. If you flip a number, you're getting its reciprocal. Let's see here if I spelled that right. R-E-C-I-P-R-O-C-A-L. There we go, reciprocal. So 14 then is an E. And now this one's very short. To express as a product of two or more quantities. Well, when you turn something into multiplication, you are factoring. So this is a factor. Just to double check, F-A-C-T-O-R. Pretty easy, that one. So 1 is going to be a T. And then for this one, it's even shorter. A power in which all the factors, or a product rather, I gave away the answer, a product in which all the factors are the same. So like 2 times 2 times 2, that would be a power of 2, or whatever. P-O-W-E-R. So we get 2 out of this one, actually. That's kind of nice. 5 is O, and then 22 is R. Now we have the final 15 questions that'll help us fill in the rest of these. So we have the first one, 11, a sum of monomials. That would be a polynomial. See if that fits. Yep. So P-O-L-Y, polynomial, N-O-M, another M, I-A-L. Yep, that all checks out. So 18 then is A. And now for this next one, a polynomial. They kind of hinted this one here. A polynomial with 2 terms. Well, that's a binomial. B-I-N-O-M-I-A-L. So 10 is B. And then a polynomial whose greatest monomial factor is 1. So if something's factors are basically itself and 1, we would call that primes. That one was a little trickier. But this is basically a polynomial who we wouldn't bother factoring because 1 was the only factor we could take out of it. So that's P-R-I-M-E. So that's 3 for P. And then 11 gets another E. Now for 14, the set of whole numbers and their opposites. So whole numbers and negative numbers, which is the opposites here, that's going to be integers. So I-N-T-E-G-E-R-S, integers. So 7 is I, and then 4 is R. So we're getting pretty close here. Just one more, 3 that we're going to get out of this one. A polynomial equation of degree 2. A second degree polynomial, we have a term for that. That's called a quadratic. So Q-U-A-D-R-A-T-I-C, quadratic. And then 16 is going to be Q, 19 is R, and finally 13 is T. So we filled in all of these blanks. We're wondering, why does the U.S. Mint need a new building? 2, I think it's 2 instead of top, because then the next word makes more sense. So to provide better quarters. Oh, because the mint creates quarters, and the place where you would house the mint would be the quarters of the mint. All right, till next time, Mr. Sutton signing off. They don't pay me enough for this one.